Okay, so what I want to do is I want to go over the homework with you guys. And I'm assuming the 11 through 14 were easy, right? Like if you can't do these questions, then let's just do them because I want you to see that it is super easy. So number 11, 12, 13, 14, they want you just to figure out the mean, the variance, and the standard deviation. So let's go ahead and just write this here. I got to slide it over a little bit. So I'll do it here on the side. So the mean, the variance, and the standard deviation. And now this happens to be stuff from a binomial distribution, right? And I don't think you can see this, but so this is a binomial distribution. And what you have to remember is that the mean is equal to n times p. The variance is n times p times q. And the standard deviation is just the square root of the variance, which is the square root of n times p times q. That's all. So number 11, they're like, okay, n is 80 and p is 0.3. So if you want to find the mean, all you do is here's the mean, right? The mean is n times p. That's going to be 80 times 0.3, which is 24. And you're done. You just found the mean. And if you want to find the variance, then you would just do the variance is n times p times q. So it's going to be 80 times 0.3 times, what's q? Yes, q is 0.7.
Check the intercom, check, 1, 2, check the intercom, check, 1, 2, 1, 2, check.
Why is q 0.7?
Well, it's 1 minus 0.3, but it doesn't matter if you put like the 0 behind it.
No, it doesn't matter. Doesn't matter. So, the answer is 0.7 because if our success is 30%, then our probability to failure, because P stands for success, our probability for failure is 70%. Okay? Does that make sense? So that's why it's that. Once you know your P, you know your Q. So what does that come out to, by the way? That's 24 times 0.7. That's a 16.8. So that's our variance. And so what's our standard deviation? It's a square root of our variance, which is the square root of 16.8, which is approximately, what's the square root of 16.8? 4.099. You could do that. You could do, in this case, 4.1 if you wanted to, 4.10. It's up to you how you wanted to round that. 4.099 is a very good answer. And that's it. That's the same thing you would do for number 12, for number 13, and number 14. So this will be one of the questions on your upcoming quiz, which I think those of you who are paying attention, it's impossible for you to get this wrong. It's so good, man. I haven't ate that in ages, especially pan con, yeah, it's con mantequilla, right?
Just make you feel better. This is very also like, it's not as good as it could be in the school.
It's true, yeah, it's true.
Yeah, no, but there's something about it. I'm very hungry now, so everything there like looks amazing.
So that's just gonna be like
Yeah, just like that. I'm asking you to do the mean, the variance, and the standard deviation for these numbers that come from a binomial distribution.
that's
Oh, there's more. I'm gonna give you one of those, and I'm gonna give you like one situation like that, but with multiple things. Yes,
Is, Q, is there always gonna be one minus P?
it has to be. It's defined that way. No. See, Mr. Chait might have. I'm pretty sure Chate's prepared. Questions or concerns? All right, so let's do number 15 together, and let me obviously move the board so that everybody can potentially see. And let me see if I can lasso that image. It'd be nice if I can lasso the image. Yes. Okay, so that's a great question. Her question was, she doesn't understand why the Q is 0.7. Okay, so let's start like this. You have a 10% chance of succeeding in something, right? Then what's the percent chance of failure that you have left over? That's all it is. That's it. So it's always 1 minus whatever P is. And we always represent P as a decimal, not, sometimes you get a percent. If something is written in percent, you make it into a decimal. Does that make sense? You could do it out of 100, but then remember to make it into a decimal. You divide it, if you divide any decimal by 100, you move the decimal over 2 times to the left, you're good. Okay. Let me see if I can lasso this so I can put in some other part. Let's see, cross my fingers. Is it gonna work? Is it gonna work? Is it gonna work? Is it gonna work? And of course it didn't work. Of course not, because it would be awesome. All right, so I'm gonna pick a color I don't usually use, guys. It's called purple. So let's read the question, number 15. You're taking a multiple choice quiz that consists of 5 questions. Okay. How many questions do we have? So auto, and it's 5. Amazing. Thank you, Melissa. You're gonna make me feel like a teacher. Yes.
So the X is like just the results of N?
The potential results
So
of,
it'd be like from 0 to 5?
yes, and that's
It's
a,
always like.
yes,
depending on-
depending on what we're talking about. And it's always like that. It's always like that. 0 is a potential result. It says here, each question has 4 possible answers, only one of which is correct. So question number 1 has 4 possible answers. If only one is correct, what would be your probability for succeeding in getting that question right?
like 0.25?
Which is 1/4, right? Which is point. Agree? Now, if P is 0.25, what is Q gonna be?
0.75.
Agreed. 0.75. Okay, good. To complete the quiz, you randomly guess the answer to each question. Find the probability of, so part A says, find the probability of exactly 3 answers correctly. Of exactly 3 correct answers correct. So yes, 1 minus that. So A, probability of X equals to 3. B, at least 3 answer correctly. So that means probability of at least 3 or higher, correct? And C, less than 3. So we're going to do all 3 of those. It's a great question. So I'm going to go ahead and reference that down here. In fact, I'm going to try to lasso it right there. So I'm going to lasso it and bring it down. And I'm going to take my time and try to explain it. And guys, if you don't understand something, you need to tell me, please. Okay. So this is number 15. Nobody's using this tablet or something similar in their class? Just me? Oh my gosh. All right. Well, maybe you should tell them about this technology. You should also tell them that they should start fasting. Right? Wouldn't it work? Okay. I guess you guys think that other people will be so sensitive about that information. Okay, so look at A. Look at A. A says probability of X equals to 3. So what do we do? What's the first thing that we do? The first thing that we do. The probability of X equals the what? NCX, you're right, it's 3, but NCX, P to the X, Q to the N minus X. That is your binomial distribution formula. So in A, they're interested in a probability of 3. All right. What's N here? What's X? What's P? What's Q? And what's 5 minus 3? Does everybody understand how I substituted into there? You see that? Now remember, this here, I skipped that step, but it's N minus X, which is 5 minus 3, which is 2. That's how we got it. Okay? So now, what's 5C3? It is 10. Now, how are you going to do it? Selma, how will you do 5C3? I showed you how to do it with the calculator, bro. 5C3. The comment. Oh my gosh. Why don't you even try? All right. So if you do it with the calculator, it should. Does everybody understand how to do it with the calculator? Melissa, are you good with the calculator? Do you do that? Make sure. Okay, here, let me show you. So here's your calculator. Now, if you come over here, you can see me press the buttons. All right, so you would press 5, and then you press second, and you see the 8 on top of the 8, it says NCR. That's a C, right? You do that, and then you press 3, and then press equal. You get 10.
Oh, so
Yes, of course.
5, second,
8,
8,
3. Yep.
okay.
So if you're using that calculator, press 5, 12, go to the C, equals 3. Yes. So put the number 5. Shift, well, shift. Division, right? Because C, and then start. 3. Now. 5, second, 8, 3. Got it? Right. I showed you, right? 5, 12, C. Got it? Sorry? Good problem. In your case, you have to find the problem, which is. Oh, damn it! What just happened? There, it came back. No! All right, let's try again. You got. So this is, it's not math, it's not, I think it wasn't stat high. There you go. So options. I'm scared of this. Expose. So I think yours is it's not that. Oh, I did it last class. I was like, oh, I'm so cool. Then okay, so it's not count. So if I press press this, it's wrong. This one. Right? You gotta be here. Yes. Okay. And it didn't stop recording or whatever. So 5, right? Second, this initiates the C. Right. Okay. Anybody else need me to show them how to do an calculator? That's no good. Yeah. You might as well use an abacus. Okay. If you don't know how to do a calculator, that's okay, but I think everybody should. But just because we're doing this class, if you didn't have a calculator with you, what you have to remember is that NCX equals n factorial divided by n minus x factorial times x factorial. So you get 5 factorial divided by 5 minus 3 factorial times 3 factorial. And then you multiply this as 0.25 to the third times 0.75 to the second. And so you know this is 10 times 0.25 to the third times 0.75 to the second, right? So that's 10 times 0.25 to the third power times 0.75 to the second power, and you get 0.087891. And that is the probability of x equals to 3. Did everybody get that? Yes, it is. In fact, if I would be doing a test, I would probably answer this as this.
Yeah.
That's what I would do. But again, I don't know anything. Questions or concerns? Again, please, guys, develop the habits necessary to help you do well in school. Not only well in school, but those same habits transfer to every single aspect of your life. Can I proceed to part B? Are you guys, wait, can I do it? Okay, so now something I should talk about. And let me see, because I sent a text to a gentleman and he hasn't written back to me, so I'll just call him during lunch. So what's the probability of x being greater than or equal to 3? Well, the probability of x being greater than or equal to 3 will be the probability of x equals to 3 plus a probability of x equals to 4 plus a probability of x equals to 5. Now remember, and this is something that's a consequence of this. The value of x, and I can't remember what this was talking about. The original question, it was talking about a quiz. On this quiz, your random variable x stands for how many questions you got right. You could have gotten out of the 5 questions, 0 questions right, 1 question right, 2 questions right, 3 questions right, 4 questions right, or 5 questions right. So when we say the probability of x at least 3, it's going to be 3, 4, and 5 that we had to add up together. So that means that you have to do this 3 times. Now, the great thing is you already did the previous one, right? You already did that. But now you have to do 5C4 0.25 to the 4th times 0.75 to the 1st plus 5C5 0.24 to the 5th times 0.75 to the 0. Oh, my wife just asked me, what should I eat today? Let me respond. It's not going to be taco today, but I would. Let me tell her that I want to eat pollo. 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 There. Can't go wrong with chicken, right? I would like chicken with ribs, though. That would be amazing. Wait, let's see what she responds, because it looks like she's just not cool with it. Look what she wrote back. Tropical. That means I gotta go buy it. Okay. So that means I got to pass by Pollo Tropical.
You know, when that happens to me, like when you're eating chicken and like it tastes like, too much like chicken. You know what I mean? It's just, like, very-
Yes, I know what you're saying, but that only happens to me when I'm fed. When I'm not fed, chicken tastes amazing. All right, guys, what's 5C for? 5. And then you see, so this is not difficult. What's 5C5? Agreed? So now you just calculate each one of these. Your rated number, the first one, which came out to 0.087891. The next one will be 5 times 0.25 to the 4th power times 0.75. It comes out to 0.014648. Of course, the calculator is rounding a little bit, I think. The next one's 1 times 0.24 raised to the 5th times, and you know what 0.75 raised to the 0 is, right? It's just 1. So this is 0.000796. So if you add all these up, you get some answer. And now the probability of x being greater than or equal to 3 is equal to 0.103335. That's an approximation. And if I were to write it, I would just say 0.103. Is everybody on the same wavelength? You guys are kind of quiet though.
Because I saw that for, I think it's for,
Did I mess up somewhere? Okay. Where do you think I messed up, or know where I messed up? Because nobody's infallible, right? Okay, so is the first one 5C3? Is that wrong, that part? No, because we just did it. I think we're right. The next one's 5C4, which is 5 times 0.25 to the 4th times 0.75 to the 1st. I got 0.014648.
that one, I rounded up to 0.015.
Okay, that's fine. So you just, here's the thing. Round at the end of your calculations. Because what happens is when you stagger round up errors, it really gets bad. Does that make sense? So whenever you round, obviously the calculator is rounding too, right? But if you round in the part where you're adding them up together, that is going to cause the rounding to cause a stack up error. So you're stacking the errors on top of each other. Not so bad when you're just adding. But by the end, then you round again. So then your answer looks probably a little bit different than mine. Maybe even vastly different. Right? Is that true or not true? What did you get? What's your answer?
0.04.
Okay, it's fine. That's close enough. But do you agree that perhaps it would be better to round at the end? Oh, well, let's try the next question. Let's do number C. C says the probability of x being less than 3, which must equal what? The probability of x equals to 0 plus the probability of x equals to 1 plus the probability of x equals to 2, because it's less than 3. So go ahead. Let's proceed. This is going to be 5C0, 0.25 to the 0 times 0.75 to the 5 plus 5C1, 0.25 to the 1st times 0.75 to the 4th. Oh my gosh, no. And then the next one would be 5C2. The board could move with me, but I would have to make it like difficult, like different. 5C2 times 0.25 to the second times 0.75 to the third. And now you have to execute all that mathematica.
That's the part of we were the last with 5C5 and you got the 0.00796 and I did on my calculator got 0.0097.
Yeah.
All right, so let me see, maybe I wrote it wrong. You didn't get a 7 anywhere there?
I did, but it comes
After the
after the 9. It's not 796, it's 976.
All right, so let me go ahead and see what I typed in because it's possible I made a mistake. Oh, I see what I did. I wrote 0.24 to the 5th power. So you guys are correct. 0.25 raised to the 5th. I wrote 0.24 somehow. And so it comes out to 0.0. No, you guys are right. I'm sorry about that. 0.000977. And so now that changes the complete answer. And now guess that the rounding is going to end up being 0.104 anyways. So thank you for correcting me. So I wrote, instead of 0.25, I wrote 0.24 to the 5th somehow. That's the only problem I have with TI Inspire. I'm not used to the buttons of it. I'm more like used to the TI-84, TI-89 button scheme. So let me make sure. And so the answer for B is 0.103. 516 is what I got. And then that rounds up nicely to 0.104. Okay, now let's continue with the rest of the stuff. So we got 5C0 times, that's 1 times 0.20. So this is 1 times 1 times 0.75 to the 5th, right? And so that's just going to be 0.75 raised to the 5th power. That's 0.2370305. The next one will be 5 times 0.25 to the 1st times 0.75 to the 4th. So 0.25 times 0.75. Look, I did again. I wrote a 74. I caught myself doing it. So go back and raise it to the 4th. It's because the button scheme is different. Times 5. So I'm getting 0.395508. Of course, there's rounding going on there. It's just I'm waiting. What's 5C2, guys? 5C2 is 5?
No, it's
10. 10 times 0.25 to the second times 0.75 to the third. So that's going to be 0.25 to the second times 0.75 to the third equals times 10. And so that comes out to 63672. So now we have this plus that plus, let me make sure. Plus this. So I get 0.896484. So that is a probability of X at least 3. I might want to round this to what? 0.896? Make sense? Good? Bad? You guys are so sad. Are you hungry? Well, it looks like I'm eating pollo tropical. So when I get home, well, as I'm driving home, I'm gonna go ahead and pull out of my dame un pollo entero, arroz, y frijoles. And then I'll get home and I'll eat both las pechugas. I'll eat a little bit of rice. I'll eat a banana. And I'll drink a Coke, a regular Coke. And then I'll drink a Coke Zero, and I'll drink a liter of water. And then hopefully I can go to the bathroom after that. Because then you get movement and you go to the bathroom, right? Is that what you guys do?
Do you drink Coke? Do you know?
I have to, I don't have to. But I choose to. It tastes so good. All right. Well, look, guys, guess what we've done here? We've created a lot of information here. The probability distribution has 0, 1, 2, 3, 4, and 5. And it has probabilities, right? If you look at probability for the 0, it came out to be point. I'm gonna go 2 decimal places, 0.24. Here's what I'm at. For 0, it came out to 0.24. See it? It was 0.237305. This is not part of the question. This is me extending this. For 1, it looks like it's 0.40. I'm doing 2 decimal places, okay? 0.40. For 3, for 2, it's 0.26. Oh no, what just happened? Give me a second. It's 0.26. That's what we got for an X value of 2. We got 0.26. For 3, in the previous question, 5C3 gave 0.09. Is it okay for me to write 0.09? For 4, it gave 0.01. And for 5, it gave 0. Essentially 0. In order for it to register, I have to add an extra decimal place because it won't register. All right. So let's just keep consistent. Just say 0. Okay, but it's very small. It's very small. And what happens when I add up all these probabilities? What should I get? What should I get when I add up all my probabilities? What do I get? I get 1. Sometimes you get 0.99, 0.999, 1.01, 1.001. We've done this before, right? So if I, like right now, what I can ask you to do now is to graph this. And you have 1, and you have 2, and you have 3, and you have 4. And your vertical axis represents the probabilities, right? These are your x's, your discrete random variable in this case. That stands for, oh, I had to put 0. I forgot 0. I'll just redo it. 0 is a possibility. 0, 1, 2, 3, 4, 5. So you got 0.10. I'm picking my scale, 0.20, 0.30, 0.40. So for 0, it's 0.24. It's around there. For 1, it's 0.40. For the next one's 0.26. A little bit taller. 0.09. 0.01. That's really bad. Let me fix that a little bit. It should be here. 4. The last one doesn't even register. Now, that is the distribution. Guess what type of distribution this is? It has like a tail on this side. That is a right skew. or positive skew? Yo hago el arroz, pide frijoles y pollo y doble pan. Ya lo voy a hacer el arroz. Then respond back to her. Okay. Now, what's interesting here is let's analyze the numbers we had. We had n equals to 5. P equal to, what did P equal to here? 0.25. What did Q equal to?
0.75.
Great. Now, what I want to emphasize to you is if P is greater than Q, a lot greater, we tend to have a right skew. All right. If we would have done this with n equals to 5 and P was 0.75 and Q was 0.25, if P is less than, sorry, let me flip it around. If P is less than Q, we would have a right skew. If P is bigger than Q, we would probably have a left skew. Not probably.
I was confused. I was like, isn't 75 greater than 25?
Sorry, that's my mistake. Now, the reason this happens is because the way the formula works is if P starts off being small, the X values will be higher, okay, when it starts out. So if you look here, like let's look at this here. So here, this number here is bigger. But when we start out, the X value here is small, but here it ends up being, when we do the subtraction, it makes this number higher than it would otherwise be. It's just the way the formula works out. Okay? Yes.
Can you explain how next to the X, we have topic of X, you got the 2440.
You see 5C0 here? 0.25 to 0 times 0.75 to the fifth. That is a probability of exactly 0, which is this, 0.237305. So I just took that and rounded to 0.24. I got it from the things that we did, yes. On the test, I do not expect you to graph. I expect you to do like the homework. The reason I'm doing this is because I'm pretending to be a teacher.
Okay. Can I go to the bathroom?
Yes. So I'm just extending the stuff. So if P is greater than Q, you have a left skew. What do you think if P is equal to Q? What would it be? It would be symmetric. Now, so in this case, we have something that looks like this. In that case, we have something like that. Well, I should make it more skewed because that looks pretty symmetrical to me. So left skew. You just saw right skew. That's not that skewed. Whatever, you know what I mean. And then this one's nice and even. Now, there's another little issue here that happens that we're not really talking about, which will come later in the book. If n times p is greater or equal to 5, and n times q is greater or equal to 5, the binomial distribution starts becoming normal, or becomes approximately normal, which means it's approximately a bell shape, like, but not just a bell shape, it's normal. So that's not interesting right now, like whatever, but just kind of keep that in the back of the mind. And is that enough for you guys? Or you want more?
You already did 16. So you-
And I already did 16. So the only one you have left to do is 17. I think that's enough. Agreed? Okay, so let me go ahead and stop the lecture and end this and end